Okay, so the session is being recorded and will be, excuse me, will be posted later this afternoon in the recorded presentations part of this Blackboard page. And what we're seeing today on the screen, what we have scheduled for is this 6.8.2 lab for configuring network address translation for IP version 4. And I'm going to be doing this on, I'm going to be performing this on actual lab equipment, 2 actual 2960 switches and 2 actual 1941 routers. Warning, Will Robinson, the lab assumes you're using a 4000 series, like a 4321 router, and those interface ports have the 2 slashes instead of the 1 slash. So wherever in the lab it says G0/0/0, I'll just be typing G0/0. And wherever it says G0/0/1 on the router R1, I'll type just G0/1. So it'll be accepted by our particular machine. Okay, so I'm going to go ahead. I'm going to take this slightly out of order for convenience sake in the lab. I'm going to configure S1 and S2 by themselves first, and then they tell you to put in, the line VTY015 and put in the telnet code. And that way, later on, when I want to come back and check it, instead of having to go and swing the console cables, because I only have 2 console cable connections at my desktop PC, I'll be connected to R1 and R2, and I'll just telnet back to S1 and S2 if I need to be able to check the configuration on them. They have a couple places where they ask you to ping something from S1 or ping something from S2, and that way I don't have to swing cables. And that should work just fine with that telnet function that's built in. Okay, I'm going to minimize the lab. I'm going to minimize my TC Blackboard. And let me go ahead and configure the PC workstations first. They don't give you a specific instruction in the lab to configure these 2 workstations. They just give you the chart on the front page. So I'll go do that. Let me see. I'll go PCA first, PCA. And I'll click the static instead of dynamic. And PCA is going to be kind of a weird address. They're giving the PCs in this lab the addresses they normally give to the switches, and they're giving addresses to the switches they normally might want to give to a PC. But it's entirely arbitrary. 192.168.1. I'm on PCA 2. And they don't give you the default subnet, the default gateway in the chart, configuration chart, but you do have to put that in. But they won't be able to ping other networks. So the default gateway is that 192.168.1.1 address for PCA. PCB's friendly neighborhood router is the G01 port of R1 that they're most closely connected to. And we'll do a little ping test here before we do any natting to make sure we got good connectivity. Got to click both OKs and click the close for it to take effect. And then we'll verify with ipconfig. And it looks like that was okay. He's 1.2 and PCB. He's 1.3, isn't he? Okay. So click this. Use the following IP address. And 192.168.1.3. And his default gateway is 192.168.1.1. Click both OKs and hit OK and close. Then we'll bring up the DOS prompt, type ipconfig, and he should be okay there. Now let's see now, just for fun, can he ping 192.168.1.2 his neighbor? Sure he can. They're both connected to 2 unconfigured switches that are plugged into each other, and there's no VLAN or anything on this lab. It's just all one standard broadcast domain. Okay, we've configured the 2 host machines. Now I'm going to do the slightly out of order part, and I'm going to skip to page 3, halfway down page 3 on our lab, and I'm going to do the configuration on the switches. Okay, now this switch should be totally and completely erased, but we can check that. We can go to the privilege exec mode, and we can type the dir command or the show flash command and look for the presence of a file called vlan.dat, and it's not there. So there's no VLAN assignment stuff that we have to erase and reload. And then if I tell them to show me the startup configuration file, it's not there either. So that's our double check that our switch is okay. We'll do the same thing on the switch 2. That's going to be switch 2. Go to the privilege exec mode. Show flash. Show flash is actually totally equivalent to dir. They just put the dir in there as an alias because people are used to a Windows machine typing dir to get the list of the files in that directory. So there's no VLAN.dat file, and if I ask him to show me the startup configuration, there's not something present there. So we're free to configure these switches now according to what he tells us to do there, middle of page 3, step 3, configure basic settings for each switch. So I'll go to the first switch here. That's the one that's going to be ultimate S1. We'll check this with Cisco Discovery Protocol after we're configured to make sure our wiring is correct as well. I always like to do that before we get real far into the lab and make sure everything's cool. So go to the global configuration mode, and we're supposed to give this guy a host name of S1. Prop changes immediately to S1. No IP domain lookup. So if I'm making typing errors, I won't hang up for a second. And then what is the command to, what is the secret answer to this question on little c? Let's assign class as a privileged exec encrypted password. If I was going to do just the regular password, I would say enable password class. But we're supposed to use the secret form. If I do enable password class, I do a show run, it'll be in there in the running configuration in plain text. So instead I'll say enable secret class. That's what we normally have. So we do here. And that way, if I do show run, it's encrypted and you can't tell what it is. It's very difficult to reverse encrypt in V5. Now we're going to say line console 0, password Cisco, and enable logins using that password. And then line VTY, these are the telnet ports, virtual terminal ports, 0 through 15, password Cisco, login. I'm recording, I'm audio, everything's cool. Okay, good. And that lines we just put in there, that's going to allow me to telnet into that switch from the router, so I don't have to swing my cables around later. And I'll just have to know the password Cisco and then the passwords class. Now we're going to do service, configure terminal, service, password encryption, service, password encryption, and that'll slightly encrypt the console passwords and the VTY passwords. They can't be just read off the screen easily. And then he tells us to put in a banner, message of the day, and we use any delimiter character we want to. Authorized users only here. Now I'm going to skip the step about the interface range shutdowns is considered. I'm at the little step H on the top of page 4. It's good practice to shut down the ports you know will not be used, so that if someone gets in the wiring closet and plugs in an unused port to try to get access to your network, and they're not authorized to, the network port will be shut down. They won't be able to get there. The switch port will be shut down. So, but I do need to put in this interface VLAN 1. So I'll say interface VLAN 1 because we need to provide an IP address to them so we can ping from them. There's some ping tests you can have us do from S1, S2. And also I want to be able to telnet into them from the router's consoles later, and he has to have the IP address for that. IP address is 192.168. There's a misprint in the lab on the near the top of page 4. The step where it says our little I configure the IP addressing, and he says S1, and he gives you the address for S2. It's because the front chart page says switch 1 is 1.11 and S2 is 1.12, and if you look at the answer key, the iOS listings in the back of the lab, that agrees with that. So I'm going to use that. 192.168.1.11 is what switch 1 is. And do no shutdown on that port. And then we need to provide the IP default gateway of 192.168.1.1. Then we're instructed to copy this to the running configuration in the RAM memory, which we have active right now. But if the router were to be turned off and on again, it would have it anymore. So we're going to do a copy run start, which is a legal abbreviation for copy running config startup config. Now I'll do the same sort of a thing for switch 2. So let's give him his host name. I'll go to the global configuration mode, and he's going to be a host name S2. And no IP domain lookup. That's a legal abbreviation. No IP dolo. And then we're going to do enable secret class. So that sets up password. Now line console 0, password Cisco, and login. And you can put those commands in either order, which you get an annoying error message. If you do it, I'll show you with a line, VTY 0 through 15. If I say login, he warns me that you enabled logins, but there's no password has been set yet. Okay, password Cisco. I said it there. It has same exact effect, except you get to look at 15 error messages if you do it out of order, but it still configures it. Okay, service. That's being called. Service, password, encryption, and then banner, message of the day, authorized, users only. And then we'll skip the interface range block out, and we do need to create the interface for the VLAN 1. And he's 192.168.1.12, the second switch is. And then do no shutdown. And let's check real quick, show IP interface, brief, and make sure that those interface addresses are good. That looks like it's good. Let me go back and check on one, show IP interface, brief. He looks like he's up and up as well. And they're plugged together. They ought to be able to ping each other. And can 192.168.1.11 ping 12? Yeah, that's okay. They're connected together. They should be. So if I do a show CDP neighbor, right now, from S1, I see that my only neighbor is S2. My port number 1 connects to his port number 1. He can't see any of the routers yet because the routers are in their default unconfigured state, and all router ports are shut down by default. On switches, the ports are not shut down administratively by default. They're ready to come up and up without people having to configure the switches, because most of these switches that ship into business and industry don't get configured. They just want to be a fast 24-port switch. Now I'm going to swing my cables over to the routers, and I shouldn't have to swing them back anymore. Okay, now this top one should be connected to R1, and this bottom one should be connected to R2. And it looks like an erase router because it's asking that question. So I'll say no to both of them, and we'll have to wait a moment for that to go past. So now I'm able to skip back and go to page 2, step 2, the bottom part of page 2, and we're going to configure basic settings for each router. Now also on this part here, he fails to tell you to configure any of the IP addresses on R2. He gives you good information on R1, but he doesn't give you any hint about what R2 is. But we'll just look at the chart on the front page, and we'll configure the R2 settings to be what he puts in there. Okay, so I'll start with R1. I'm going to start right from the explicit steps he's given here. Looks like a non-configured router. I'll go to the privileged exec mode. If I show the startup configuration, yeah, there's no configuration there. Okay, so let's go to global configuration mode and give him a host name of R1. And then we're going to go no IP domain lookup. And then enable secret class. Then we'll do line console 0, password Cisco, login allowed. And then line VTY 0 through 4. Oops. Line VTY 0 through 4. Password. That's Cisco, login. The next step we're supposed to do is do a service password encryption. And then a banner message of the day. Now, we're given specific information. I'm near the top of page 3 on the lab. Little step H, we're going to actually configure the interfaces on G. The lab says G0/0/0 because I used a series 4000, like the 4321 router. to do this lab on, but our routers are 1941 routers, and they only have 1 slash instead of 2 slashes. So if I tried to type interface gigabit 0/0/0 right here, it would blow his mind. He says, I don't know about that. Well, if you're ever at a router, do show IP interface brief. The IP interface brief command or the show protocols command is a great way just to look at a router and see how he numbers his interface ports. So on this particular machine, our 2 main Ethernet ports are G00 and G01, not G000, G001. So I'm going to have to say interface G0/0, and it took it. That's a legal interface port numbering scheme for this particular machine. IP address, and here's our weird. This 209.165 looks like a global unique public IP address. It's actually a reserve address for training and documentation, but we're going to treat it as like a global address we can NAT to the outside world. 209.165.200.230, and this /27. 255.255.245.248. Doing no shutdown on that port. Then interface G0/1, and he's supposed to be an IP address of 192.168.1.1. That's the default gateway for the 2 host PCs. Standard /24. Doing no shutdown on him. And then we were instructed to create a default route, IP route, quad 0, and the exit address is 209.165.200.225, which means that it'll be a recursive lookup, and the routing table will have to look up the IP address and then determine the exit interface from that. It's an Ethernet-based multi-access network, so the best practice, if it was a serial port, point-to-point serial port, we could say 00001 and save a recursive lookup. And then I'm instructed to save the configuration, copy, run, start. Now, is this enough information to do show CDP protocol, show CDP neighbors, and can I see my neighbor? So I can see S1 as my neighbor. R1 is supposed to be connected to S1 through R1's G0/1 port. Is supposed to go to the F0/5 port on the switch, and it does. It matches. We haven't configured R2 yet, so we won't see anything at this point. Okay, so a quick show IP interface brief. Make sure my addresses are proper here. And R1 is specified to have the 209.165.200.230, and that looks okay. If I did the subnet mask correctly, and G0/1 is supposed to be 192.168.1.1. So here's why I like the command show protocols. It's show protocols, what it is. Show prot for short, because it shows you the IP address and the subnet mask. So that 209.165.200.230/29, I said 27, so /29. That's correct. That's the 255.255.255.248. It's 5 binary bits and 3 zeros, 3 host bits. Okay, so I think those addresses are good, and I did do a copy run start. Now, here's the steps he doesn't give you, but we'll just use the front of the page, the addressing chart, addressing table on the front of the lab for this. So I'm going to go to router 2 and complete the same steps he told me to do on router 1, but I'll change the addressing information to match what's proper for router R2. So let me go to the global configuration mode and give this guy a host name of R number 2. And then no IP domain lookup, and then enable secret class, and then line console 0, password Cisco, login, and then line VTY 0 through 4, password Cisco, and enable logs. Then we're going to do the service password encryption. And then the banner message of the day. Authorized users only. Oh, got spelled correctly, unauthorized. And then we'll do these interface ports that are on. Before I do the interface ports, let me do a show running configuration. And we can see that the enable secret password has been MD5'd to this 128-bit. That's the best you can do with the ASCII codes on it. And if we had not done the service password encryption, these lines down here would say password Cisco, password Cisco. But instead we did service password encryption, so now we can't see what the passwords are. They're slightly encrypted. Not as powerful as MD5. You can go to many places on the web and you can reverse engineer the service password encryptions. MD5 is much more difficult to reverse engineer. Okay, now we need to put some IP addresses on here because I don't think we have any IP addresses yet. Show protocol. No IP addresses. Show IP interface brief. They're all administratively down. They have no IP addresses yet. So let's just use a chart on the front page for R2. And instead of G000, it'll just be on our machine, it'll just be G00. So interface gigabit 0/0, which is the one that goes back to the other 00 port on R1. And R2 is supposed to be IP address 209.165.200.225.255.255.255.248. Doing no shutdown. And then we're going to create a loopback port. So interface configure terminal, interface loopback 1, and loopback ports 1's IP address is 209.165.200.1 with a subnet mask of 255.255.255.224. There's that /27 I was talking about. And you don't have to do no shutdown. Show IP interface brief. Make sure I got that proper. So gig 00 on R2 is 209.165.200.225. And the loopback port is 209.165.200.1. And let's do a show protocol just to make sure I got the subnet mask correctly. So 209.165.200.225 is the 248, and that's the /29 that matches. And then the loopback port is 255.255.255.224. That's a /27. 209.165.201. Okay, I think my addresses are proper. Okay. Now we need to add. I didn't add the default route, did I? So let's add that default route. No, that default route's only on R1. I don't do that on R2. So if we look at the routing table, R2, we see our directly connected 2 ports. That's the gigabit 00 port and the loopback port are up and up. We look at our routing table on R1, which is what the switches and host machines PCs are attached to. We see our 2 Ethernet ports on R1, 2 physical Ethernet ports, and we also created that default static route. So we have that S* entry. So that'll point back to the 209.165.200.225, which is the next hop link from router R1 to R2. So he should be able to, in theory, be able to ping that loopback port address later. He's going to have us try to do that stuff. Then we're going to put in some network address translation and see if it works with the network address translation. Okay, I've done the switches stuff now. So now if I go to R1 and show me your CDP neighbors, I can see my connection to S1 that we saw before. Port 1 of my router R1 goes to port 5 of the Ethernet switch to the left of it in the diagram on the front page of the lab. And R2, which is on the right, the G00 port of R1 goes to the G00 port of R2. So they're I call that, they're kind of cored together on their 0 port. Okay, we're going to skip page 3 because we did that already for the switches. Let me check and make sure that I can telnet to those devices now from R1. So can I ping 192.168.1.11, which is the first switch? Okay, I can. So can I telnet to that address? How about 192.168.1.11? Is password Cisco. Look, I'm telnetted into the switch now. There we go. Can I telnet into switch 2? 192. Let me try pinging it first just to make sure. Ping 192.168.1.12. And the ping is okay. So let's just type this address. Cisco enable class. Yes, I can tell that's in just fine. Now I won't have to swing the cables over anymore. Okay, now we're at R1, and we're at the middle of page 4, and we're gonna actually put in our first 3 different NATs we're gonna use in this lab. They're gonna create and destroy some NATs. So we are given the command on step 1, little a, part 2, step 1, little a, go to the global configuration mode, and put in access list number 1, which is a standard access control list, which only can permit or deny based upon the source address. Permit 192.168.1.0. Anybody whose network address is 192.168.1. anything, because this wildcard mask is 0.0.0.000, the first 3 octets must be 192.168.1. All ones and last octet of the subnet mask means I don't care what your last digits are. So you can be 192.168.1. any possible other number in that 4th octet. And this access list will permit you. Okay, now we can create our first NAT pool, IP NAT pool. And now he says public access. I'm going to just call it capital PA. It's a PA system. So I have to type all this stuff out, save my terrible typing. And now we're defining the range of addresses that will be granted to our 192.168 clients on our inside network. We have a range of addresses to the outside world that we're going to use. 209.165.200.226. From that to 209.165.200.228. So I've got 26, 27, and 28. That's 3 addresses that I can use. And then the net mask for that network is 255.255.255.248. That network, not the network you're on. Okay, now we're going to say IP NAT inside source list 1, that network, that access control list we made up, to pool capital PA. Now we have to define our inside and outside interfaces from R1. R1's our NATing router. So I'll go back to the pure configuration mode and let's specify interface gigabit G0/1. And that's the inside port, IP NAT inside. And then we'll say interface gigabit configure terminal interface gigabit 0/0. And he's IP NAT outside. Now, just before I do anything here, I'm going to do a show IP Nat Translations. Show IP Nat Translations. And there's no translations that have taken place yet. At the bottom of page 4, we're going to make a translation. So what we're going to do is go to PCB. So I'll go down, find my PCB. And I'm supposed to ping from PCB, I'm supposed to ping the address 209.165.200.1. And it looks like it worked okay. So let's go back to our router, R1, and let's repeat that show IP NAT translations command. There's our translation, it worked. So it translated the inside local address, the 192.168 address, like your home router network would use, to that global address on that side as well. So that seems like it's fine. So what was the inside local? Well, they just gave it to you for that. I don't have to say that. Now, from PCA, go back to PCA. I'm still on PCA here. I'm supposed to ping the 209.165. I just did that. Hold on. So PCA ping the loop back to the interface. Oh, I was supposed to use PCB. Okay. So ping 209.165.200.1. And then I think we need to go back and check our NAT translations table. There we go. So now we have 2 translations. We have the translation from PCA, We have the translation from PCB. Now let's go to S1. Let me see if I can do this from R2's console. That would be convenient. So if I go to S1 and telnet into him, he was 192.168.1.11. Does it say S1? No, S2. Oops. Oh, did I forget to type the command IP default gateway? Oh dear. Okay, I'll skip that for now. It's supposed to fail anyway. The reason is we only have 3 addresses. We only did that 26, 27, and 28 address. And if we tried to do more than 3 devices, the other devices are already hogging the connection because it's like a 24-hour timeout. Okay, so I think now we're ready. I'm going to go back to R1 now, and we're going to go to the bottom of page 5, and we're going to clear the IP Nat Translations table. And we also need to clear the IP Nat statistics, because we're going to do a new NAT now. We're going to use the no command, no, which reverses pretty much any iOS command you put in the device. If you want to get rid of it, you just type the whole thing out again and put the word no in front of it. So I'm going to do the global configuration mode, and I'll say no IP NAT inside source list 1 pool PA. And then we'll add the port address translation for overload for this. IP NAT inside source list 1 pool PA, and do the overload keyword, which means use port address translation. We can use our port numbers to keep these physically unique devices separate from each other in the NAT table in much the same way as a desktop PC keeps different applications running on that one PC separate using port numbers at the TCP level. Okay, now I will do again a show IP NAT translations, and there's no translations taking place yet. And then at the bottom of page 6, we're instructed to go back to PCA. Show PCA. And we're going to ping, so that same address in N, 209.165.200.1. Okay. And now let's go back and do our show IP NATs. And we have the translations. Okay. There's only one translation. Send the ping once more and quickly go back to the router and see what happens. So I'll sing it once more. I'll quickly go back to the router and send the command again, and it still only shows 1. Translation timeout now is, I was supposed to type show IP NAT translations for both. Oops. There we go. Now it shows us a timeout. So it's only like 1 minute timeout now. It was a 24-hour timeout before. Now generate traffic from multiple devices. We're going to go to PCA and PCB and do a non-stop ping. So that's ping 209.165, ping -T. -T means ping forever, no stop. 209.165.200.1. And we'll go back to PCB and do the same thing. Ping -T 209.165. 209.165.200.1, and now he's pinging continuously. Oops. Ping, ping. I messed up the command. Ping -T 209.165.200.1. There we go. Now they're pinging continuously. And then we go back to R1 and show IP NAT translations again. And we see those 2 devices are pinging. Okay, now we're going to clear out this one, and we're going to go to the more conventional situation. And instead of using static mapping, static NAT, we're going to use dynamic NAT, which is what your home router does with overload, so that you would be able to use as many inside devices as you have at home. Okay, he didn't tell us to, but I better stop and go back to PCA and PCB and stop those pings. Okay, let's go back to R1 and let's destroy what we did and put in the new one. So first of all, we're going to clear IP NAT translation star, and we're going to clear IP NAT statisticals. And now we're going to go to the global configuration mode, and I'm at the bottom third of page 7, step 4 on R1. Let's remove this is the second existing NAT pool translation that we did. No IP NAT inside source list 1 pool. P8. We're creating, and oh, no overload, please. Okay, that took that away. Now we're going to say no IP NAT pool P8. Okay, now step 5, we're going to add the pat overload command for this G00 port. IP NAT inside source list 1, referring back to our access control list number 1. Interface G0/0, not G00, and then overload statement. Okay, step 6 at the bottom of page 7. I'm going to go to PCB. Let me bring up my PCB. And I'm supposed to ping. He just says ping at one time, 209.165.200.1. And it's okay. Let's go back to Router R1 and do our show IP NAT translations. And it's being translated, okay. Now we're going to go to PCA and PCB, and we're going to use the nonstop ping thing again. So let me see, it should be in my command history. There we go. And then I'll go to PCB. Oh, I'm on PCB. Go back to PCA, use my command history. Now they're both pinging them both like crazy. Now S1 and S2. Let me see if I can do this on S1 and S2. I wasn't able to do it S2. Maybe I can go to S1 though. So S1 is 192.168.1.11. Cisco enable class, and we're going to use the command ping 209.165.200.1 repeat. I'll just put and possibly large number. And let's go back to, let's see, can I can't log out, I can't log out within this weekend. I'll have to stop this because I control shift 6, X, shift 6, X, stuck, I'm stuck, oh no. Okay, so stop all the pings. I'll go, let me go to, stop this one, go to PCB, stop this one. And let's see, I've used all my tricks here. It's Control Shift 6 and then X. Oh, that worked. Okay, good. So we're back to R1, show IP NAT translations. And there's our translations that took place there. We couldn't use the one from S. We got 3 lines instead of 4 because for some reason I couldn't get into S2. I probably forgot to use the IP default gateway or something like that. Okay, now we're going to do the static NAT for IP version 4. And this is typically used when you want within a company, if you've got a server, like our Web Advisor server or our MyTCC Blackboard server or the TCC-SC-Edu. Those are static servers. They can't be dynamically mapped to any old address because the DNS tables couldn't have one static entry in them in the rest of the world. So when you have a static router that you want your customers and trading partners and stuff from the outside world to be able to connect to, you do a static mapping, a one-to-one static mapping. And it has to be the same exact known address every time so that it'll work out just right. Okay, so at R1, I'm going to go ahead and clear the IP NAT translations. And I'm going to clear the IP NAT statisticals. And then we're going to say create a static mapping. IP, gotta be in configuration mode. IP NAT inside source list static. And then we're going to put the IP address of 192.168.1.2, and that's going to translate to 209.165.200.229. Enter. Oops. What did I do again correctly? Let's see. IP NAT inside source. Oh, I put the word list. It doesn't belong there. IP NAT inside source static 192.168.1.2, and that'll be translated to 209.165.200.229. There we go. It took that. So on R1, let's do show IP NAT statistics. Well, we're still on R1. Show IP NAT translations, not statistics. Let me get that translation. It's a static translation. So I should be able to ping from R2. Am I connected to R2 still? There we go, Cisco. Can I ping? Can I possibly ping from R2? Can I possibly ping 209.165.200.229? And it worked. On R1, I'm not going to show the show IP NAT translations again. And now we've got that extra entry for that static mapping that we just did. Okay, that verifies that static NAT is actually working properly. Okay, I've covered everything that's in the lab now. So let me see, I'm going to stop recording, and this presentation will be placed up on the My TCC Blackboard soon later today. Noon today. If you're, hold on. My mouse back. So the suggestion has been made. You can still register for this career fair. The suggestion has been made by our upline trainers at the Education Service Center, our Cisco Parent Academy, that maybe they'll turn on the cameras. Maybe you should dress like a job interview here. And if they turn on the cameras, you can look, ready to work and serious about this stuff. There'll be our 5 hiring employers will be here talking about the hiring market for CCNA type people here. Even early career people that have just got their certification and they really haven't worked as a job for the CCNA yet. Okay, I'm going to stop the recording.